All right, for example 3, based on the data in the table, how many residents would you expect to vote in the 7th town council election? Now, if you take a look at what's going on here, and again, just the first thing you want to do with that is just kind of take it at the most basic level. What's happening to the numbers, getting bigger, smaller, that kind of thing. So it looks to me like the number of voters is getting more, the total residents is getting more, right? So both numbers are increasing. We have actual information about how many people are in the town, right? And the only thing we're missing is how many voters we have there, right? So when you have a kind of a binomial set of data here where you have two numbers basically, one number compared to another number, right? This got bigger, that got bigger, this got bigger, that got bigger, this got bigger, that got bigger, this got bigger, that got bigger. If you look at just a quick little addition thing here, that got up by 28, and then it went up by 37, and then it went up by 49, 93, then it went up by 56 plus 23 is 79, and then it went up by 77 plus 67, 144. So there's not any really rhyme or reason to this increase, right? And I mean, this went up by 200 and something, this went up by almost 300, this went up by 800 and something, this went up by a little over 600, almost 500. Yeah, so it's kind of, there's not like a little, there's not any specific, it's going up by this much each time, right? So it's not your basic pattern. Okay. What I like to do with a binomial set of data is look to see if there's a relationship between the ratio of one thing to the other, either residents over voters or voters over residents, doesn't matter which one. All right. I'm going to go voters over residents. I like to get decimal numbers for a ratio instead of bigger than one number. So I'm going to go small over big. So what I'm looking at here is there some sort of a voters to residents, is there some sort of commonality equals some constant number? And when I say constant, I mean constant loosely. All right? It might not be exactly the same number, but they're kind of close to the same number every time. So if we try that out, this would probably require use of a calculator. It's not going to be simple math. So if I look at year one, if I do voters per residence, I've got 386 over 3511. All right, so I grab my calculator, wait patiently for it to open. So I'm waiting patiently, but anyway, there we go. All right. So we go 386 divided by 3511 equals. So 0.1099. In year two, we have 414 residents, or sorry, voters out of 3,790 residents. I get my calculator again and type in that ratio, 414 divided by 3790 equals, comes out to 0.1092. Year three, we have 451 voters out of 4,085 residents. Divided by 4085 comes out to 0.1104. Year four, we have 544 residents divided by 4,900, voters divided by 4,907 residents. Get the words wrong. 544 voters over 4,907 residents. We divide that one. 544 divided by 4907 comes out to 11.09%. 0.1109. In year five, we have 623 voters out of 5,562 residents. So 623 divided by 5562 comes out to 1.1120. And finally, year 6, we have 767 voters out of 7,014 residents. 767 divided by 7014, that comes out to 0.1094. These are decimal versions of what could be a percent, so 10.99%, 10.92%, 11.04%, 11.09%, right? So each time, if we look at the percentage of voters in this town, it looks to be right around 11% of the voters, right? 11% of the town votes.
Yeah.
So when we have 7,786, what we're doing is to get this divided by this, to get that percent, we're going to multiply that percent here. So if I just put 0.11, because again, it's not constant, it's constant-ish, right? It's not exactly the same number, but they're all right there around 11%. If I assume 11% participation in the election, I'm going to take the total number of residents times 11% to get how many residents that will be. So that's going to be 7,786 times 0.11, which is 856.46 people. So year 7, I would expect, what was it again, 856.46. I'm going to go with 856 people, or voters. Partial people don't exist, all right? So that's a situation where people is the answer, voters is the answer. Whole number makes sense, not decimal number. So when we get a decimal, we round. I would say somewhere in that neighborhood of voters is what we should expect for turnout.